Hello everyone, welcome back to my channel Science Sutra. In this video, we are discussing about the combustion and flame. This chapter is under the grade 8. Okay. And till now, if you have not yet subscribed my channel Science Sutra, please do subscribe and hit a bell icon so that if I upload a new video, you will get notified. Thank you. Yes, in this video, we are discussing more about combustion. Okay, what all substances can undergo combustion and what is combustion, some instances where we can control combustion, all these we will discuss in this video. Okay, first and foremost, what we need to understand is about combustion. What is combustion generally? Combustion is a burning. Okay, combustion is nothing but burning of substances. Okay, so I will say the combustion is a chemical process. Why? Because see, if I take a paper, okay, I will burn the paper. How I will burn the paper? By lighting that with a matchstick, correct? By using a matchstick, I am burning the paper. Okay, and I will say the burning of paper is a chemical process. Why? Because whatever the substance that we obtained after burning of paper, what we will obtain after burning of paper? We will get ash, correct? This ash is different from paper. So chemical process in the sense whatever the substance that we are getting, it will be different from the substance that we have used. So we are saying that process as a chemical process. So how we can define the combustion as combustion is a chemical process, okay, where the substance will react with the oxygen to give heat and light. So how can I write the definition for combustion? It is a chemical process, okay, where the substance undergoes chemical change, okay, in presence of oxygen, okay, to give heat and light. Okay, the best example, if you want to give the best example where the substance that show a chemical change or that show combustion, what is the example that you will give? You will give the example of magnesium ribbon, the burning of magnesium ribbon, right? If you burn the magnesium ribbon, okay, what you will get finally? You will get heat as well as light. So the whole process of burning of a magnesium ribbon, which results in the formation of magnesium oxide, and finally it will give out heat and light. The whole process you will call that as combustion. Okay, the example for combustion, if they ask you to give the example for combustion, you can give the combustion example, that is the burning of magnesium ribbon. That also you can give. And one more example, if you heat the charcoal, okay, if you heat the charcoal, what happens? It results in the formation of, okay, it results in the formation of production of heat as well as light. So this is also a combustion where you will see a chemical process. Okay, even if you burn the coal, what finally you will get? You will get ash, correct? So that is also a chemical process. So the combustion, this is how you can define the combustion. Then what kind of substances that show combustion? The best example of the substances that show combustion, are fuels. Fuels are the substances that show combustion. As we all know, we are all familiar with the fuels, right? Fuels, in the sense, you can see solid fuels, okay? You can see liquid fuels, and you can see gaseous fuels or gas fuels, you can see. Okay, what is the example for a solid fuel? If you want to give an example, it would be wood as well as charcoal. Wood and charcoal comes under the solid fuels, right? So liquid, the best example for liquid is petrol and diesel. Okay, petrol and diesel comes under the liquid fuels, correct? Gas fuels, LPG. Next, CNG. What is LPG? Liquefied petroleum gas, and CNG is the compressed natural gas, and one more, that is biogas. And we all know this LPG is stored in the form of cylinders, and that cylinders we will use in our kitchens, right? This is a fuel that is used in the automobiles, correct? Petrol is also used as a fuel for an automobile, diesel. All these are the best example for the substances that show combustion. So, what are combustible substances then? If you want to define what are combustible substances, these are the substances that show combustion. Okay, combustible substances that show combustion. The best example for combustible substances are fuels. Okay, in fuels we will see three types, that is solid fuel, liquid fuel and gas fuel. Okay, and this is about the definition of combustion, and what else we have learned, what are the products of combustion, correct? And we have learned about the examples of combustion and the substances that show combustion, correct? Now let's see this activity. What is this activity? Means we have to classify the substances whatever they have given in this table as combustible or non-combustible. Okay, let us do one by one. Wood, do you think it is a combustible substance? Yes, this comes under combustible. Paper is also combustible substance. Iron nail. See, if you supply heat or if you supply some energy for the iron nail, do you see any combustible or do you see any thing that is coming out from iron nail similar to wood or paper? I don't think so. This is a combustible. This comes under non-combustible. Kerosene oil. Yes, if you heat the kerosene oil after some time, after reaching some temperature, after reaching to a temperature, what the kerosene oil will do? It will catch the fire. So this is a combustible. Stone piece, that comes under non-combustible. Straw, that is also a combustible substance. Charcoal, combustible. Matchstick, combustible. Glass is a non-combustible substance. Okay. Like this, we can classify the substances as combustible and non-combustible. Next, what is the topic that we need to discuss is about the conditions that we require for combustion. Can we see the combustion process in a closed room without having any air or vacuum inside? Okay, can you do that? That we need to verify. How we can verify that? We need to do this activity. What is this activity means? First, we have to take the burning candle. Then we have to place that burning candle, okay, on this table like this. We have to leave some space, okay, and we have to cover that with a glass. What happens? If you cover the glass, the burning of candle will continue, okay. By leaving some space, you have to do this. Okay, if you leave some space, what happens? The air that is flowing, it will flow inside the glass also, and thus it results in the burning of candle. Okay, if you close the lid completely without giving any gap, what happens? The air that is coming or the air that is present outside will cannot enter inside the glass. As a result, there is an absence of oxygen supply. As a result, we are seeing the candle to be offed. The flame of this candle will be offed after some time if you do or if you cover the glass completely. Okay, and what that shows, if you see the flame of this candle to be what to say, if you see this flame of the candle burning, okay, you will say that combustion is taking place. But if you are not seeing the flame of this candle, what that represents? The combustion has stopped, correct? So what we can say finally, for the combustion to take place, oxygen is very much required. So we can say oxygen is required for combustion. From this activity we will get to know, you can do this activity at home. It is very easy. From this you will get to know, for the burning of substance or for burning of anything, what is mean or what is very much important? Oxygen is very much important. Air is very much important for combustion, for showing combustion. Okay. And we have to discuss some instances. Okay, how we can control the combustion. Okay, I will give some instance where you will see oxygen is an important part, or oxygen is plays an important part for combustion. One example which I gave is the candle, right? I will give two more examples for you. Okay, what are the examples means? You have to take the burning of charcoal. The burning charcoal you have to keep on the tawa. Okay, or on pan you have to keep. And what you have to do? You have to close this tawa or the pan with a lid. Can you see the burning of charcoal inside? No, you will not see the burning of charcoal inside. Why? Because you are cutting down or you are making the air that is flowing inside the tawa or pan. What you are making? You are not allowing the air to pass into the pan or tawa. As a result, the burning of the charcoal will not take place. Thus, you are making the combustion to be complete, right? You are not continuing the combustion. If you want the combustion to be in the off mode, what you have to do? You have to cut down the oxygen supply that you are providing for this burning, correct? So what is the next example I can give means, okay, if a man or a woman, if they have caught with a fire, what you will do? Immediately what you will do? You will wrap their body with a thick blanket. Why it is so? Have you ever thought that? Why they are wrapping a thick blanket around the person who has caught with a fire? What happens? If you wrap their body with a thick blanket, the oxygen that is supplied for burning, it will be cut off. Okay. If you wrap their body with a thick blanket, the oxygen supply will be cut off. As a result, the burning of the fire will not continue. Okay, it will get stopped. So, what the person will do? The person will not get further hurt. So, what we have to do? If the person is caught, or if a woman or a person is caught with a fire, what you have to do immediately? You have to wrap their body with a thick blanket. As a result, the fire, whatever fire they have caught with, will not destroy or will not do much more wounds to their body. Okay, so what you have to do? You have to wrap their body with thick blanket. Okay, like this we can avoid or we can control the combustion process by just cutting off the oxygen supply. Okay. Next, we need to understand about this ignition temperature. What is this ignition temperature? We need to understand. See, if I take a paper, okay, if I take a paper, what I will do, I am bringing the matchstick, I am bringing this matchstick near the paper. What the paper will do? Paper will immediately catch the fire from the matchstick and it will be burnt. So, and I will take wood, okay, and I am bringing the matchstick. Do you think the wood will catch the fire as like the paper catching the fire from the matchstick? Do you think so? No. The wood will not catch the fire as easily as the paper will do. Okay. And one more, if I take the kerosene oil, okay, and I am bringing that on a Bunsen burner, do you think immediately will this kerosene oil catch the fire? Do you think so? No. What the kerosene oil will do? It will absorb the heat from the Bunsen burner. Okay, after reaching some temperature, after reaching to an temperature, what it will do? It will catch the fire. Till that temperature, it will not catch the fire. Okay, so how from this what we have concluded? The substances, different substances will catch or will undergo combustion differently. Correct. So the paper, if I talk about the paper, paper will have much more fastly it will undergo combustion compared to wood, compared to kerosene oil. Okay. So the different substances show different kinds of combustion or different times of combustion. It will show at different times it will undergo combustion. So, what is ignition temperature then? Different substances will have different ignition temperatures. Okay. So, how I can define the ignition temperature as? The ignition temperature is, it is the lowest temperature, is the lowest temperature of any substance. Okay, lowest temperature of any substance to show burning. Okay, is called, what do you call that kind of temperature as? Ignition temperature. Okay. The temperature at which it is the lowest temperature of any substance to show burning. So if I take paper and wood, which is having low ignition temperature, paper will catch the fire easily compared to that of wood. Okay, if I take wood and kerosene oil, which is having less or which is having a low ignition temperature, kerosene oil is having a low ignition temperature compared to wood. Okay, like this, the different substances will have different ignition temperatures. Till that temperature, it will not burn. If it reaches that ignition temperature, then only it will burn. If you are supplying the heat to that substances, okay, if you are supplying the heat to that substances till its ignition temperature, then only it will burn. Otherwise, if you are supplying that heat or something to the substances lower than the ignition temperature, it will not burn. Okay. So the ignition temperature plays a very important role for burning of the substances. So the matchstick, do you think the matchstick can burn on its own? Do you think that? No. What the matchstick need to do? It need to strike the rough surface of the matchbox. Then only you will see the ignition of the matchstick. Why it is so? Because the matchstick need to attain its ignition temperature. then only it will show the fire, or then only it will burn. Correct? So this matchstick is said to have a history. Do you know? It was discovered 5,000 years back only by Egypt people. Okay, how they were using the matchsticks during that time? They were using a pine wood. Okay, the name of the wood is pine wood. That wood they have dipped in sulfur and they are using that as a matchstick. Okay, later on what they have discovered? They have discovered whatever the black surface that we are seeing on the matchstick, no, that is made of antimony trisulfide, the chemicals that we are seeing in the black surface of the matchstick. What that black surface is made of? It is made of antimony trisulfide, potassium chlorate and white phosphorus. Okay, and these three all mixed together using a glue. Okay, and they have applied on any wood surface. They have applied on any wood surface like this, and what the matchstick need to do, it has to strike against the rough surface, and so it will start burning. But later on this white phosphorus was found to be very much dangerous for the people, those who are manufacturing the matches, and for the people those who are using the matchsticks. So later on what they had what they have made means they have changed that matchstick as safety matchboxes, and the chemicals they have used there is antimony trisulfide, potassium chlorate they have used. But for this rough surface which we will see on the matchbox now, they have made of the glass with little red phosphorus. This red phosphorus is little dangerous compared to the white phosphorus. So when this matchstick is bought and struck against the rough surface, what happens? The red phosphorus which is there on the rough surface will get changed to white phosphorus. Sorry. And the white phosphorus get immediately react with the potassium trisulfide. Okay, and these two mixtures will give heat. That heat will ignite the potassium chlorate in the matchstick. As a result, we are seeing the fire out of matchstick. This is a very long process in order to get a small fire. Okay, I hope you like. Yeah, this is about a combustion process, examples for combustion, and how we can avoid the combustion, correct? And all this we have discussed in this video. If you like this video, please like, share and subscribe to my channel Science Sutra. Thank you very much.